Hey there, and welcome to my spaceship. Today, we are going to be celebrating the birthday, well, birthday of the James Webb Space Telescope. So on December 25th, 2021, 3 years ago, James Webb was hurled into space, and it brought back some pretty awesome things. So first, James Webb is this in the image right here. So it has these mirrors that help reflect images like this, except this is all computer generated. It has 7 layers of heat protection, essentially, because the telescope needs to remain cold. James Webb has a few instruments, 4 tools specifically, that help it gather really clear images in a way that we haven't seen before. So first we have the near-infrared camera, we have the near-infrared spectrograph, the mid-infrared instrument, and the near-infrared imager and slitless spectrograph. All of these combine to bring back really amazing and clear images that we haven't seen before. So here we have webbtelescope.org, which is where you can find all the information on photos, resources, anything you want from James Webb. So they, when you come on, you can immediately see that they have a slide. You can pause the video on whatever, but they have a slide of images that Webb has sent back. And you can immediately click on Image Gallery. So I like to go back to 2022 because that's the first time they sent back images, and apply. And this is what you get. These are the first images that, first data of all kind that is sent back. So we have the new milestone in redshift, measuring redshift. And redshift is when the light from objects that are moving away from us is redshifted because the wavelength is longer. Go back. Then we have the North Ecliptic Pole Time Domain Field. So this image, which is four images put together to make one view, is actually quite small in our sky. Almost 1 year after James Webb was sent up into space, it sent back images that they made into this. And so when you scroll down, you can see there's downloadable images. There's the permissions, which is a good thing to read, and when it was released. December 14th, 2022 at 11 a.m. is when they released the image to the public. And so here you can see that it covers 2% of the full moon in the sky. So the size of the full moon in the sky, it covers 2% of that. And then it also tells you what they used. So here was imaged with Webb's near-infrared camera, so the NIRCam that I mentioned earlier, and it gives you some of the wavelength range right here. Oops. And just some other information that you'd like to know if you were trying to really study this. So especially the colors, which are all listed right here. Okay. So when you click on this camera, you can zoom the image. they bring all of these smaller things into a little wider of a view so you can see what they are. This one very clearly is a spiral galaxy, or at least a barred spiral. We have some other galaxies. We have some really close together. This right here looks like an interacting galaxy. You can see some of the shared dust. That's pretty telling of interactions. And as with most of the wide range views that James Webb has sent back, besides a few of the spiky stars, everything you see is a galaxy. And that's pretty amazing. And if you are interested, they do have a quick facts section that you can scroll through and read all of the information that you need. This is where you get the instruments that are used on James Webb, what they do, how the mirrors work. You can scroll and you can read quite a bit more. And this is all here. I will link this in the description of the video for anybody who wants to come and read about James Webb. These are some of the first images that James Webb sent back. This one right here was actually the first image that was pulled onto a computer screen by a scientist. In this one you can see a lot of gravitational lensing, which means that these are all further away and being stretched. The light is being stretched around something that has a large mass of gravity. Over here we have 4 interacting galaxies. You can see 2 right here that are very far into the merger, and another one joining, and one almost there. James Webb can also let us see into the dust clouds that Hubble wasn't able to see in before. Because of the different cameras and the newer technology that James Webb has, it can actually see through some of this dust. So all of these new stars that you see in here glowing blue, and some of the older ones that help feed the new ones, you can see before. Over here we have a supernova seen differently than we were able to with any other telescope before. We can see further into it. We can cut through some of it over here to see behind it even. And you can see one image over here has a single source. However, if you look over here, there's actually 2. And that was very surprising because before we couldn't see the second one in this wavelength, but we can over here. And that's something that James Webb brought us that we weren't able to do before. I'd like to compare some of the Hubble and James telescopes because that's one of the purposes of James Webb, is to look at things that Hubble already looked at so we can study it even further in a different light, and we can learn new things just based on comparing images from Hubble to now. Remember, Hubble was sent into space in 1990, which is significantly earlier, a whole new era earlier than Webb. But here we can see, you can see the visible light of NGC 7496. Over here, the Webb image, you can see the structure of it. You can really see the arms a lot clearer, and you can even cut through some of the dust in the center to see the bright center. And now we have an even clearer view of the pillars of creation. So this was the image that Hubble had for many years. You can see the very thick dust clouds that are the creators of the stars, and all of this dust behind it is now wiped away by Webb. So Webb can cut through a lot of the really thick dust. Obviously, there's gonna still be some, but it can cut through a lot of the thick dust and show you all of these stars that are within being created. And it can even show you behind the dust. The differences in these two images is very important because Hubble can show us what we would see, but then James Webb can show us what's actually happening within. And one of the newer images is the Sombrero Galaxy. So this was Hubble's image of the Sombrero Galaxy, which is what we would see if we were to have a very large telescope and look at it with our own eyes. This is the light that our eyes can pick up. We have a lot of the dust all around here, which is what all of our galaxies have, except the Sombrero Galaxy does not have any arms. But with Webb, it cuts through all the bright light and the dust to show you how the structure actually is. This would be the halo, which you see down here as just bright, bright light. And that bright light cuts into what you can actually see of the structure and what you can see behind it. But here, that bright light is taken away because it's a different wavelength that they're looking at. So you can see behind the Sombrero Galaxy, you can see the stars in the halo, and you can see the structure, the actual structure of this entire inside part of the galaxy. So the James Webb is located in the L2 region, which is about 1 million miles from Earth, and it's orbiting the Sun with the Earth. It was made to complement Hubble, which I showed in the comparison images. It's important to see the Hubble images too, because you can actually see what you see in a Hubble with your own eyes. But if you want to study what's within, you need James Webb. But there's also an upcoming space telescope that it's also designed to complement, and that's the Nancy Grace Roman Space Telescope. So as I showed before, Hubble captures the ultraviolet, visible, and near infrared images, where James Webb, as I said in the beginning, specializes in near and mid infrared. And one of the most important things about James Webb is how far back it can see. So when we look at galaxies and stars farther away from us, we're seeing them as they were millions, even billions of years ago. So James Webb can see galaxies that formed mere millions of years after the Big Bang. And the Big Bang was approximately 13.8 billion years. That's the most accurate aging we've had. And today is its anniversary of being in space. That's pretty amazing. So again, I will link the website to James Webb in the description. But for now, I would like to thank you all for coming and celebrating James Webb's birthday with me, and Christmas if you celebrate Christmas, and I'm pretty sure today starts Hanukkah as well. So, have a happy holidays, everybody, and thank you. Remember to like, share, and subscribe.